Now I want to introduce today's speaker. We have Dr. Carmen Gispert. She's an area viticulture and pest management advisor with UC Cooperative Extension in Riverside County at the Palm Desert Campus office. Today, she's going to be speaking on monitoring for Western Grapeleaf Skeletonizer in wine grape vineyards. And so now I'm going to go ahead and pass this over to Carmen.
Thank you, Cheryl. Hello to everybody. Let me just start with sharing my screen. Thank you for the introduction. I am the viticulture advisor, and I have been working with this pest, which has been quite interesting to really invest as part of my program, this particular insect. That because it is an insect that has existed in California for a long time and has not been a problem for quite a few decades. So I'll tell you and share with you the story about that. So let me go ahead. So this insect is, as it says on the slide, is called the Western Grapeleaf Skeletonizer, that goes by WGSL. And it has been distributed in California, Arizona, New Mexico, Texas, pretty much the western part of the US, but also exists on the northern parts of the states of Mexico. It was first found in California in 1941. At that time, the entomologist did a lot of searching, trying to see where this was coming from, what was it was a risk of as a pest, and what could we do to really understand the extent of the problem. And about 20 years later, it was found in backyard grapes in Fresno. So it was a concern that it has been moved quite far, and the entomologists needed to understand what could be done to prevent that it could keep moving. I'll tell you a little bit about the life cycle for you to understand what is the approach that, as an IPM manager, should be taken in account to develop the program. One of the things that are very, very important, of course, is to understand and learn about the pest. This is a moth, and it's a beautiful insect that when it flies is really dark, but the wings have multiple colors that with the light of the sun, when it hits the wings, it really turns like a rainbow. So it's very, very, very pretty. Of course, that's something that only the entomologists can say. The growers really just don't care about how pretty or not that is. But it's really easy to recognize it because the color and the shape and the size is about maybe at least one, like 3/4 of an inch. And it flies during the mornings, so it's easily recognizable. One thing that is also easy to recognize is the way it lays the eggs. Probably you go, if it's too hot, for example, probably you won't be able to see the insect flying, or if it is in the afternoon, they might not be flying. But something that I could recommend is to start looking for it under the leaves. You will see this nicely arranged of those kind of pale yellow color, a very line up distribution of the egg under the leaves. After about 2 weeks later, those eggs hatch and develop the larvae. And the next slide, I will show you the different sizes of the larvae. They have 5 stages, but this would be very easily recognizable. Most of the times when the larvae are about this size and this shape is when the people start recognizing them, and that not before. But now with this presentation, probably you will be curious just to learn that you can even be aware of the presence of this insect on the egg stage. So after the larvae, because this is a moth, the next stage will be a pupae. The pupae are found on the crevices of the grapevines, that there are some of the varieties that really have a loose bark, but they will find anyway some areas where the larvae will hide and they'll produce the cocoons. And during the winter, that would be what you will be looking at. Sometimes it's quite difficult, but some thing that I have found that is useful is if I have already learned and I have seen the damage previously, I mark the vines and I'll come back during the winter to be able to see if I can recognize the pupae. So in this slide, you will see on the left top corner some of the kind of the translucent pieces that was where the eggs and the larvae have already emerged. You see they continue having a very nice kind of organized layout of the larvae, and that's what this is easily recognizable. This insect. At the beginning are kind of whitish, yellow, bright, kind of translucent shape and color, and they start turning a little bit yellow. By the time that's going to the second, third, but the fourth instar is the one that I tell you that is most of the time when people start calling me that they have those insects with those bands on the body. And they even grow a little bigger. And then that would be the fifth start that in the winter would be the one that will develop the pupae. One feature that over the years, it was very, very important for the entomologists that were working with this pest, trying to understand, was that it was found that in some areas, the nicely layout of the eggs was not as well as it was in other parts of the vineyard or other vineyards itself. So in this slide, as you can see, and it has the label here that those are infected eggs. They found that the distribution of those eggs were quite loose. And over time, they found that after being very nicely organized and kind of in clumps, the larvae start being all scattered, all this under the leaves. They were scattered all over with some kind of dark spots, and that was something that calls to them their attention. So they realized that those that they were having this distribution were sick. And the reason that was calling them to be sick was that it was discovered with the research that was done over a long time that what was causing the sickness was the presence of a virus. That was quite interesting because it was found that this naturally occurs in the vineyard. And they did some trials and actually took those larvae that they were sick and they would dry them out, and they make kind of a powder of those leaves that had those larvae that were already sick. And interestingly, they went ahead and spray kind of loose that powder on some of the leaves that they were with the presence of the pest. And over time, they found that it was actually working as a natural control. So at that time, another entomologist at UCR took off that research and developed, ran some tests and developed a program using the virus, identify the virus and develop a program as an approach, a natural approach to use the naturally existence of the virus itself. So to use it as a control method. Another thing that they also saw, besides the scattering of the larvae and during the growth of the larvae, was that some of them start kind of getting attached to the leaves, and they were not able to complete the cycle. So that meant that they were sick. So it was a good sign that this was naturally happening, and it was adding a tool for the entomologists to start testing if this could be used as a control method. In addition to that, they also found natural enemies, and one of them is a tachinid fly that was laying the eggs on the larvae, and also found a parasitic wasp that also was laying the eggs on those larvae. So it was very interesting that the presence of the virus and those two other insects were contributing to kind of contain the pest, because it was not expanded. But it was very, very good that they went ahead and started really looking for, trying to understand what was happening with this pest, that they found those natural enemies and the natural control itself of this pest. All of this really has helped to introduce and use that information to develop an IPM program. In addition to that, the areas that were infested, they found, number one, that the most dangerous stage of the pest was the larvae, because they are very, very voracious. They eat all the green part of the leaves, and they only leave the kind of the main veins. So I have seen some of those vines that have been pretty much eaten by the larvae, and they leave what we call the skeleton, and that's the reason why this insect is commonly called the skeletonizer. And I should add that the fifth start of the larvae develops a very kind of stingy features at the end of the abdomen, that when the growers by mistake manipulate the vineyards, they get stung. And they also kind of on the arms, when they are moving the arms through the canopy, they get stung, and it's quite painful. So not only we are concerned about the damage that causes, because it can defoliate completely a small vineyard. I have seen the problem in a small vineyard. I have the case of one grower that went on vacations 2 weeks. And when he came back, he had a small vineyard, probably about 500 vines. I did not assess how many of them, but the ones that were infested and affected by this insect were completely defoliated. So that was done just before he was going to harvest. So the fruit was exposed to the sun, and it caused sunburn. So he pretty much lost the crop that year. So it's, again, not only the damage of the insect on the vine itself, but the concern of the vineyard manager in case this is in a commercial vineyard, to expose the workers to the stinging spines that this insect has on the back. All of you have, of course, been attending those IPM talks, and this is just a kind of a refreshing and highlight why it was the motivation for me to work with this insect. As all of you well know, one of the things that starts really the development of a program is the inspection. So in my case, as an advisor, I get the calls because the growers start working in the vineyards, and they start looking that something is quite different. So they're curious and then go ahead and inspect the vines, and then they take pictures. All of this is just to highlight why is very, very important to maintain a continuous inspection of whatever problem we are having. Once we have or identify, okay, there is a problem, could be an insect, could be a disease, could be different symptoms, could be just a malformation of the leaves, whatever is determined that is the problem. So it's identified that is a problem. So we need to see if that is and find if there is an insect, we need to identify it. If it's a disease as well, we need to take samples and be sure who we are going to be dealing with. There have been cases that I have been getting some samples, and in one case on table grapes, I was able, with the really collaboration of a plant pathologist I use in Riverside, to identify for the first time one fungi that was causing a lot of trouble on table grapes. So the participation of all of you inspecting and bringing the samples, calling the attention is very, very, very important. So our role is, once we identify, is evaluate the problem. For what is really what we want is to assess the problem and then to start developing some management options. And again, even if that is, and it takes some time to do that, we always need to continuously revise if whatever has been proposed is working. So all of this is to establish why is that approach this insect. Once I was receiving the calls from the growers in the Temecula area, and I was aware that this insect, in the last 20 years that I have been working there, I have never seen it, and I never had a problem with it. So in the last 5 years, then I start receiving the calls, and then I go ahead and see the damage. So this insect currently is being monitored using what you all know, delta traps. Those are the red kind of triangle traps that use a lure. That's very, very good that already a lure has been developed. And this lure has the smell of the female. So you all know that then the males are being attracted to that smell and get in the trap, and that's how we know that the insect is there. So normally it takes, I had somebody that was helping me, and it takes, either you can decide if you do the trap counts every 7-10 days. I was doing it every 2 weeks. It's very labor intensive, and it's inaccurate in the way that I go every 2 weeks, and I don't know if the insects got there the day right after I was there, or they were there really the day before I came back to the vineyard. So I have this lag of time that I don't know when the insects came in. And the importance and the highlight of what I'm saying that is because the timing at the very beginning in most of the insects is crucial to develop some methods to really reduce the population, or develop ways to do that, to reduce the extent of the problem. It's not to eliminate it, but obviously it would be more advantageous for us if we need to deal with a population that is reduced, that with a large population of the pest. So that's what the inaccuracy and the time lag between the sampling as is done really brings some challenges. So in addition to that, I needed to go count them and then communicate in some way with the growers. So I thought that probably would be very good for the growers to know right at the time when they need to start looking for the pest. So, and currently there's no communication mechanism to alert the growers for the presence of this insect. And on top of that, the importance of that communication would be to really time when to start using a control method. So again, taking in account the way and the different steps and the approach of the integrated pest management, again, I highlight why it's important monitoring the insect. I said before that the programs are based or oriented to focus our effort on the most vulnerable stage. In this case, it would be the larvae. And then that is done knowing the life cycle and following that life cycle with the monitoring directly in the fields. So I was approached by a company that has been worked with a group of developers, kind of working with the in the Department of Development in at UCR, and it was really interesting that they assemble a team with specialists on IPM and computer sciences. And they developed a trap that has some optical kind of detector. And I learned about that, and I was really interested, and I proposed to them if they would be interested in me testing this trap to monitor this insect. So what the study that I developed was that I could use this trap that has this artificial, it's called a tool as an artificial intelligence that could be tested to side by side with the regular way this insect is monitored, that is with the delta traps. So what I did was to place those two traps side by side, and this has been a study for 2 years to see if the accuracy of the detection of the trap was similar with the regular trap that is being used. I should say that the way this trap works, let me see if I have, okay. This is just for you to get the data of when the trial started and those 2 years, and it was in Temecula and I'll have this, probably I can come back to this linked if you're interested. For you to know what I'm talking about. So this is a trap that they developed, and it's quite interesting because it has a solar cell battery. So it has a chip that communicates with my computer. And what it was really interesting for me was that when they talk about we're going to train the trap. Okay, what is to train the trap? So what happens is that they are able to develop a program when the insect comes, particularly this insect. This was done only for this insect, but I have flies and mosquitoes and many other insects that are already in the vineyard. So what they do is that they develop this chip that when the insect comes flying, they develop a program that recognizes the insect for the number of movements of the wings that is unique for any insect. So that's what they talk about, training the insects. So at the beginning, what we had was to go to a place, try to find a place that was heavily infested, put the trap, and they were on the computers, and every time something comes in, they do whatever they need to do to develop this algorithm until they were pretty sure that it was only identifying the skeletonizer. So I went ahead and then put side by side the delta trap. That's the way it looks like, that you already know that this triangular, and both have the lure inside. So I put them at the same time, and then I went on my computer, and when the insect came in, certainly it was detected that was here. My assistant went 2 weeks later and compared and counted the insects in both traps. And that's the way I was assessing if it was accurate. So that's what it looks like. So I put another sticky trap inside, and that's how those insects were trapped and they were counted. So one important thing that for us to decide where to put the traps was that we were looking for some infested vineyards. So at the time that we go, the canopy has grown quite large. So it's difficult because if the population is low, they normally look for some shade, more cooler areas. Just for you to know, if you start looking for this, it would be kind of in the area where the arm or the cordon is placed. Is not way at the above on the vineyard of the vine, not really at the bottom, kind of in the middle. That would be in the area that have shade, that are a little more cooler. And this is the way you can you see them. So at the very beginning, again, those eggs, and later on, maybe in about 5 to 6 weeks, you will find those. You can see here that they have been eating already, maybe previously, and they start just showing those leaves some symptoms. Here you see when I talk about the skeleton shape, so those areas that have been eaten, so they just fall off, and then in the end we just have the main nerves of the leaves, and then that's what we find. And here you see all the green areas that have been eaten by those larvae, and it would be easily recognized that the presence of this insect. All right, so the interesting part of working with those developers and those computer science people, so what we did was to follow the development of the pest along the whole year, and we did it for 2 years. And what I was really pleased was to see the comparison with the data that we recorded with the red line, that would be all the numbers that were counted using the delta trap. And with the kind of greenish yellow line would be with the numbers that were found and counted inside the trap. And as you can see here, it matches pretty well. One of the things is that obviously it's different to have about 62 and not probably 85 is different. But I would like to highlight that after working with this insect in 2 years, we realized that the crucial time to be accurate is at the very beginning. Later on, if I have 20 difference in number of those insects, it is not that much of a problem because we should start working with it here. So this really was because we need to develop the program early. And early in the season, we see that it matches pretty good. I'm not saying that it's perfect, but for the purpose of being aware and start doing something is pretty good. So I was pleased with that. In this slide, I wanted to share with you that the way the detection program is developed and what I was able to see on my computer is that they had different codes. They have the developers of this program. They coded with different colors, the different locations where I had the traps. So when I went on my computer, I was able to recognize where was this trap and then see which one of them had the most number of insects and determine where I could probably focus and start working to follow the pest itself. So that's a nice feature that they have that they can tell me, okay, this vineyard, for example, one of the vineyards is close to the hotel of the winery. So if they need to use material that it smells bad, probably would be something that they need to be aware that, okay, this infestation is there, we need to schedule this either when in the afternoon, who knows. So the point is that it is a nice feature to let me know, not by the location, the extent of the infestation, because it tells me exactly how many insects each one of those traps have. That I thought it was really good. Also, you see in this figure on the X side of the figure, are the hours. And it tells me here, this was during the summer, this is 5 in the morning, 10 in the morning, and 3 in the afternoon and at night. So you see here that really early in the morning, just around 10 is when I have the flight, which is very important. Because if people want, that's what I was telling you at the very beginning, go in the morning. I'm not telling you go kind of in the middle of the day. And I was explaining also why you go in the middle of the day, probably you then do not see them flying. And what you would need is to look under the leaves to see if there is any egg laying. So this was also very important because this trap records 24/7. And it tells me exactly the time that those insects came in. So I thought it was quite nice. So that's another vineyard that also shows some high numbers here. And this slide is I put it here for me to remember to tell you that the accuracy is doesn't match it quite well all the time. And to this level of difference was a concern. And this is to also recognize that this is something that we need to work on. The developers told me that probably they tweaked a little bit the program that they have already set for the traps, and I needed to find an explanation of this. So what happens here is that when we went and checked the weather recorded over time, we realized two things. one that it was a period of wind. And another, in another vineyard, it was a time that was a lot of manipulation of the vines itself, because the growers were removing leaves, they were kind of reducing the crop, so they were moving the vines itself a lot. So those traps are quite sensitive. So I couldn't be sure exactly what caused this, because it didn't match with the number of insects that we found actually physically caught inside the trap. We did not find over 300 of them. We found pretty much a lot of them, but not 300 or 400 of them. So they still working on this, but again, the importance and that having the matching pretty good, and I asked them to run some statistical tests to see this accuracy, is at the very beginning to start working on developing a program. Again, in this you can see which trap where is located get most of the insects. So again, I can concentrate probably to see, okay, in this area it was the wind, in this area they were working. So it allows me really to kind of try to put together some different pieces of the puzzle. And again, it was also recorded at the timing. You see, is during the morning. Once it starts being hot, the insects do not fly. Very, very, very little. It was a heavily population between May to August over here. There's some activity, but because of the heat during this time, the movement of the insects is reduced. So, okay, that's all good that I know they fly in the morning, that I can kind of get the numbers on my computer. But really what it was important was, okay, we know already that in the past there had been some models that had been developed, and I was really pleased that one of the models that was developed was for this particular insect. And the base of that development is using what is the amount of heat that is needed for the insect to change of different stages. So the time that it takes for one stage to the next, and then with that they develop the program, and over time then they can have the development of the whole life cycle of the insect. So the term that they use to develop those programs and the models is what is called a degree day. That would be, again, the amount of heat that is required to understand how long does it take for one insect to complete the life cycle. And using that model, the developers got in addition with the numbers that we had and the time during the year, we got the degree day model. So we know how many degree days is needed for the eggs. So the next step is for the grower to go to the website, check the heat, the temperature, and even the IPM website has access to that. They can see how many degree days have already been accumulated. So when we get to this number, knowing that the pest is present, they will know that this is the time to start looking for the eggs. So that's the importance and the value and the benefit of developing this degree day model. So using the model, it tells me that really the peak of the population is going to be pretty much between June and July. And knowing that the insects started, the first year it was found on May, and the second year it was around April. But the peak is here. And more importantly, based on the degree days model, it tells me, and the findings that we got data, is when I could expect to have a second generation. With this, we believe there are 2 generations in the area, and the second generation will start kind of mid-August. The importance of this is that some of the vineyards start being harvested in August, and you can then remember what I said at the beginning about the damage that it causes. If we have the second generation right before you are ready to harvest, in 2 weeks you have the risk of defoliation and lose the crop. So that's what I thought it was quite important to expect and see and be prepared for the second generation in case we were not able to control the very first one. Because all of this, the fruit is being developed. So it's already not good news to have it here, but in case where we're not able to control the pest, we have another risk right before harvest. So this is the importance of combining all the tools that are available to develop an IPM program. This was interesting because right before harvest, you can see here some of the grapes that were already kind of drying. The grapes are ready to be harvested, and I see this kind of hanging there. And it happens that the grower applies some bacteria. It's called Bacillus thuringiensis, and I was not told. So when I went ahead and I saw them kind of hanging there, I need to find out what had happened, and said, yes, I put that bacteria, and it seems that was successful because it killed or damaged or made those sick. And then he reduced the population at that time. This brings me really to kind of come back and say part of the IPM program, when we are ready to develop the action, would be with approach either biological, chemical, or cultural, and a combination of all of them. So this is already in the IPM website. So we have been only using the Bacillus thuringiensis that is called BT, that so far it worked on that particular vineyard and reduced the population. We didn't have that much of the population. Was not that large, but and we knew we were monitoring really, really close. So it was really effective. And the BT, again, this bacteria is put when we have the larvae that I said already, that is the most vulnerable stage of the pest. But we have quite a group of different materials that could be used and that have been proved that are effective to manipulate and to control this insect. So in conclusion, we developed some data with the remote detection using the traps with optical sensors. And we believe that offers a promising approach to a more accurate and autonomous insect monitoring methods. This really gave us real-time information of the presence of the pest. It reduced the labor, and it helped us to make better decisions that probably will help to reduce the use of pesticides when we will be targeting the right stage that is vulnerable, and we'll be using the right material that is being proven that is effective. So I think we still need to work more to then develop the next stage is really line up what are the series of materials that could be used if BT doesn't take control entirely over the development of the crop, and followed with a series of already tools that we have available with other materials to keep monitoring and deciding what would be the sequence of all of them, and more importantly, the time to apply each one of them. I think with this, I finished, and I really want to acknowledge the participation of the project Farm Sense team, headed by Leslie Hickle, who is the CEO, and the developers, the program managers, and the entomologists. The Temecula and San Diego wine growers that allow me to work in their vineyards, and the vineyard managers that were really patient, just reporting when they were using different things and how were they finding the insect in which areas. With this, I think I finished my presentations, and I'll be more than happy to answer some questions if there are any.
Thank you so much, Carmen. Yes, there are two questions that came in the Q&A. I think we have time. One was regarding the optical sensor. They wanted to know if that was a camera, such as in trap view. And do you have a pheromone lure for Western Grapeleaf Skeletonizer?
Okay, thank you. Yes, I will say it's a camera. What I was told is like an eye, and what is called kind of in the technology probably would be, yes, similar to a camera that detects. It's not that they see the insect itself. Really what it is the beating of the wings what recognize the insect. It's not that sees the insect. It's not actually the image of the insect itself. The sensor is the beating of the wings. So I think the answer is not a camera. It's not that, okay, it's a fly and then tells me it's a fly. No. Is the program was developed for the sensor, and it's amazing to me. I still kind of not understand entirely how they are able to do that. It's like when we go to the stores, the door, the entrance sends our movement and opens the door, right? So it's kind of the same concept. The insect counts beats the that many times per second. That means skeletonizer, and then counts it as a 1 or as a 2 or as a 20 every time that one of them enters. I hope that is clear.
Yes, and then what the other part of that was, is there a pheromone lure?
Yes, I was really lucky that has already been developed, and that's available right now. And there is a company that sells it, so you put that lure inside, and that's what attracts the males, and that's what I was able to monitor, and anybody really. That's the way this insect is being monitored.
Do you need an adjuvant with the BT? And if so, what type of adjuvant would you recommend?
I will really need to go back and be sure. I cannot tell you the name right now. When I used, I did not use the adjuvant, but I think it would be recommended, but I don't want to tell you to say a wrong material. And it would make sense in the way that we need to be sure the adjuvant will be to maintain the bacteria there. But I'm not sure if there is one particularly that is recommended, not to influence in the efficacy of the bacteria itself. So I can look at that and let you know. Okay, thank you very much. I just want to say goodbye and thank you for your attention to all of you.
Yes, and thank you. We appreciate your presentation and thank you everybody for attending today.